In these examples, we're going to be doing improper integrals. And improper integrals are unbounded integrals for which we need to do formally with limits. So unbounded would mean that in this case here, we have an integral or an area that's unbounded at infinity. So we're going to use our limit notation to do this. So it looks like this. We're going to replace our infinity, which we can't really have as a bound, and we're going to set this up as a limit as a, we're just going to choose a as our variable, as a approaches infinity, and our integral is then going to be from 0, that's our starting point, to a, which is our ending point. And that ending point tends to infinity. And it's going to be e to the negative x dx. So once we set up the limit notation, we can just use the antiderivative of this to evaluate this limit. So we're going to end up with limit as a approaches infinity. The antiderivative of e to the negative x is going to be negative e to the negative x. And the bounds are going to be from 0 to a. We're going to set this up. We're going to use a limit as a approaches infinity. And we're going to substitute in our a and our bounds. So we're going to end up with negative e to the negative a minus negative e to the negative 0, which is really just 0. There's a bunch of extra negatives in there, so we just have to make sure that we keep track of that. At this point, I can evaluate my limit. I'm going to end up with, I'm going to simplify this first. So limit as a approaches infinity, and let's simply just make this a little bit nicer looking, 1 over e to the a minus, and that's going to be, we're going to factor that negative out, so it's going to be, we're still going to have a negative in there, not that it really matters. So it's going to be minus e to the 0, which is 1. And then now we can evaluate this limit. This becomes negative 1 over e to the infinity minus 1. That's going to be 0 minus 1, so it's going to be negative of negative 1 or positive 1. So what this means is that area underneath this curve, this unbounded area, has a finite area, and that finite area is 1 square unit. And looking at the diagram here, yeah, I guess we could justify that's going to be 1 square unit, because if we take a look at our 1 unit, so this square here, this rectangle here would represent 1 unit. So that looks like that blue area would fit inside that yellow rectangle.